welcome back for another 5 Caillou challenge called mean square error. You are to complete the function that accepts two integer arrays, you'll see here, called first array and second array. They are said to be of equal length. You are to compare the value of each member in one array to the corresponding member in the other array, which means, the first element in this one gets compared with the first element in this one, the second with the second, third with the third, etc. Squares the absolute value difference between those two values. So you'll start at index 0, take that element, subtract it from the first element in the second array. Whatever answer you get, take the absolute value to get rid of a potential negative sign, and then square that value. And finally returns the average of those squared absolute value differences between each member pair. So you can think of this like you're kind of creating a new collection, right? That's formed out of two integer arrays. You'll get another array, probably a double, and maybe not double, but the average will be a double. But you'll get a new collection containing these absolute value squares, these different squared differences. And so they give some examples down below. You've got two collections. One is 1, 2, 3. One is 4, 5, 6. And note that, let's step through it. First element, we got 4 minus 1 is 3, right? And note that it doesn't matter which order you go in. You could do 1 minus 4 equals negative 3. The thing is when you take that absolute value, you're going to get the value of 3. So 3 in the first, and then you square the 3 to get 9. So that's why they had 9. So you can think of this as what they have in parentheses here as the new collection that's generated from combining these two collections, right? It's the same length because you're deriving a value for each pair in these two collections. And then finally, based on the length of the collections you're working with, you divide by that to get a simple mean average, right? And that's what I meant when I said I was talking about doubles here, because that could come out not necessarily to integral value, right? And then feel free to look through these other examples if you're still confused. The key takeaway, they have to be the same size. We'll enforce that, but I don't think it'll come up if you choose to ignore that. But 10 minus 10 is 0. You square that, you get 0. You've got 20 minus 25, which would be negative 5 or 5. Either way, with the absolute value, you get 5. 5 squared is 25. Then you have 10 minus 5 is 5. Squared again, you get 25. And then you have 2 minus negative 2, which would be 4, right? Minus a negative is like adding. So you get 4. 4 squared is 16. And then note again, if you did negative 2 minus 2, you would get negative 4. The absolute value converts that back to 4. And again, when you square that, you get 16. I think that's enough said here. So go ahead and pause the video, try this one out. I will end up going through two solutions. It doesn't take very long. There's one nice one using LINQ if you want to try and look through your enumerable methods to find something relevant. And then I'll just do one using a basic loop and set up a variable to sort of accumulate values and calculate an average. So let's start with the LINQ. And what I like about this is that I think it shows a method, an enumerable method that we haven't looked at before, or if we have, we certainly haven't used it much in this series. And it is, hopefully you had your page open, if you scrolled all the way, if you went under enumerable methods, went all the way down, you would have seen something called zip. And maybe that wouldn't have flagged you, but here we are now. Now you get to learn it. Enumerable zip method. So applies a specified function to the corresponding elements of two sequences, producing a sequence of the results. Doesn't that sound exactly like what we're doing in this video? I mean, that's perfect. And so we'll look at an example. Again, I want you to start looking at these. I know they're really scary and intimidating at first, but they will help you and they're not scary over time. Remember that this keyword, it goes with extension methods, right? So this won't actually be, this whole bit here is the first one. It won't actually be a parameter. It means you're calling this zip method on one of these, some enumerable collection. And then you'll see the actual first argument we use will be this second collection that you want to zip with it. And then finally, we'll use a lambda to do this part of it. And you can see kind of from this signature, right? You get a first, think of it like an element from the first collection, an element from the second collection, right? We're going to need those values in pairs to sort of do our work. But let's look at the example they show below to get a better idea of how to do this. So like I said, consider this. You have two enumerable collections. They're not even of the same type, right? And remember that first one, you're calling the zip method on that first enumerable collection. So they did numbers first, numbers.zip, and then remember it took another collection for the actual first parameter inside the parentheses here. That'll be words. And then we had that delegate here. Look at this. See, you set up first, I like the names here, first and second. It's, you know, first would be coming from numbers, second would be coming from the second collection, which is words. And then you can see here they're doing a simple concatenation, just putting a space, converting it to text and putting a space between the two values so you can see how they're paired up. So I think this example is a nice illustration of how this works. And we're going to do something pretty much like this. We can copy this. So let's start. Let's break this out and sort of build it simply. So we'll say result equals first array dot zip, right? Remember that we take some enumerable collection, we get to call zip on it because there's an extension method made which makes this zip method available to enumerable collections, right? And then you pass the collection you want to zip it up with as the first argument, if you remember from our example. And I guess the way I think of the zip, right, is you almost think of like a zipper. Think of like when you're wearing a jacket, right, and it's open and you've got two rows of vertical teeth, right? And when you grab that latch and start pulling the zipper up, it sort of pulls those into each other, and the teeth sort of interlock and form the closed jacket, right? I guess if that's helpful, you could think of it like that. It's taking these two rails of teeth here and it's sort of merging them into one. And that's what you get out of zip. So if that helps you remember, I'll use their name. Let's set up our lambda here, first and second, meaning first is taking the element from the first array, second's coming from the second array, and this will handle taking them in the right order, you know, matching up by index value. And then it's the matter of what do we do? We need the body. These are our parameters. What do we do with these? Well, it said first things first, we got to get the difference of them, right? So you could say, and we know it's the absolute value of the difference, right? Because we don't want the negative values. So it doesn't really matter which order you do it because we're doing it in absolute values. So I'll just randomly say first minus second here. And then we know once we have the absolute value, they said to square that. So hopefully you remember that math also has a power class, or a POW method for power, where you can take any value and raise it to whatever exponent you want. So I use the value 2 here to square it. Okay, first array zip. I think that covers us. We'll combine this like I said, but let's kind of keep this simple. And then with enumerable as well, we know we have to take an average of this new collection. So before I get ahead of myself, zip right, what's going to be populated in result here, it's going to be another enumerable collection containing these powers. I think POW returns double. You can check that out if you want. So you do get a collection, an enumerable collection of type double at this point. So it's a collection. And so if we have these collection of doubles, how do we get the average of them? Well, if you look through your methods again, you may have noticed average. And it does what you think it does. You can see lots of overrides here. See if they have an example. I don't know that it's that important that I show an example. It's going to do what you think. It's going to take a mean here. So you can see how they have a bunch of longs here, long average. Feel free to read more if you'd like. I don't think it's that important. So I'll say return result average. And that will be a double because the types of these are double, right? Math, POW returned a double. So the collection is of type double, and average should return the same type as the elements. Returns the average of the sequence of values. Okay. So something like this. One other thing I like to do, you don't have to do this, but we should say if first array.length is not equal to second array.length. This is just me enforcing that. I don't want any weird stuff, unpredictable stuff to happen. And I want to get you in the idea of not trusting input parameters that come in. You can't just assume they're going to have valid values like you can in this coding challenge sandbox that we live in now. In real life, you just can't make that assumption. So we could, you know, just whatever you want to flag it. Is not same length. This should not trigger, but it's there to get you thinking about it. So if we try this, and look at that, I got this nice ranked up message. We're up to 3 Caillou. Bam. All right. You gotta love promotions, right? Okay, the type or namespace argument exception. Naturally, I did not bring in the system namespace that is needed for it. Exception class, and I also needed it probably for these math POW and math absolute value. So, oh yeah, you can see that down below, and there's more. Okay, green's good. And all green, good. So again, if you want to trim this up, I was trying to do this in steps so you could see it. Hopefully you're okay, and then if you want, you can just do, and if you remove my check for the lengths of the arrays, you can be that one-liner, just return a one-liner. This should be fine. Good. So I'll probably submit this version, but let's do the roll your own case. Anyone's interested in that. If you're not, if you're comfortable doing that, you can bail at this point. Double sum equals 0 to start. And we're gonna go for int I equals 0. We're just gonna loop over these arrays. You could check the first array length or the second array length here because I have this condition here that's enforcing that they're the same length. It doesn't really matter which one you use. So I could say we're going to grab each pair, right? Sum plus equals. We can essentially rip, we're doing the same thing, right? So we can say we need the power of the absolute value of the difference. So the difference being we don't have this first and second, these parameters anymore. Those should be first array I, right? And grab the value from the second array. And so you can see for each pair, each index through the array, we're going to grab those pairs at the given index, subtract them, get the absolute value, and then square them, and add that to your running sum. And finally, at the end, you can say return sum divided by first array dot length or second array dot length, they're the same. So this should work as well. I'm going to go right to the attempt. I missed something on line 15. Let's see, math array first. Yeah. So that closes the absolute value. That closes the power. I had an extra parenthesis there. Green. Okay, so you could submit it this way too. It's good. You should be able to do either way. You know, I kind of like the link stuff a lot, you know, once you're comfortable. As long as you can do it on your own, you are fine. I'm going to submit mine like this. We'll put it on one line so I can be like the cool kids. And yeah, I'll leave my check in there even though it's not necessary. They're going to make me run again. But yeah, maybe this was a good introduction to zip for you. You have another tool in your tool belt now. So submit it off, get those points. And go ahead and look through the solution. See what you can learn from other people too. You're not restricted to learning from just me. You see a zip and an average there like we did, the zippity doodah. Probably a lot of that kind of thing going on. Zip to average, zip average. So I will leave it at that. You know where to find me if you have questions or comments. Otherwise, I will see you in another video. Thank you.